Hey class, in today's lesson we're going to talk about sequences and series, which is found in section 9.1. Our objectives are to use factorial notation, to use summation notation to write sums, and to find sums of infinite series. If n is a positive integer, then n factorial is defined by n factorial equals 1 times 2 times 3 times 4 times essentially one number less than whatever your value of n is, and then finally times itself. As a special case, 0 factorial is 0, and the apostrophe mark, actually not apostrophe, but exclamation mark, means 0 factorial, and that equals 1. So 0 factorial is 1. So to solve or to evaluate each factorial expression, there is a calculator function for all of this. However, I'm just going to show you by hand how to do this. So 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 6 factorial is 2 times 1. That works for 2 factorial. And then you have 6 factorial, so that's 6 times 5 times 4 times 3 times 2 times 1. Okay, and these supposed to be dots, sorry. Okay, because this is multiplication of factors on the top and multiplication of factors on the bottom, to divide them, we can simply cancel or eliminate them from the numerator and the denominator as long as they're the same. So 6, 5, 4, 3, 2, 1 can go away with the bottom, 6, 5, 4, 3, 2, 1. And then 8 and 2 can simplify to become 4 because 8 divided by 2 is 4. So this can simplify to become 4. So we're finally left with 4 times 7 in the numerator and 1 only on the denominator. So 4 times 7 is 28. And that's your answer. On the second one, we have 2 factorial times 6 factorial. So 2 times 1 times 6 times, and this time I'm just going to stop and say 5 factorial because I noticed that there's a 5 factorial on the bottom. So this is 3 times 2 times 1 times 5 factorial again in the denominator. I could have written 5 times 4 times 3 times 2 times 1 for 5 factorial, but if it's in the numerator and the denominator, there's no point in wasting your time writing all the digits. So these will be eliminated. And then in the denominator, I have 3 times 2 times 1, which is 6. So these 3 at the bottom are eliminated with the 6 in the numerator. So our final answer is 2 times 1, which is 2. There are a lot of different ways to simplify this, by the way. This is just my way of doing it. So however you see fit to do it. Okay, n factorial would be 1 times 2 times, and this comes from the notes on the last screen. So 1 times 2 times 3 times, all the way up to n minus 1 times n factorial. Or in fact, I'll just say n, okay? Over n minus 1 factorial would be 1 times 2 times 3 times all the way up only until n minus 1. Okay, so everything in the numerator cancels with everything in the denominator all the way up to n minus 1. And so we're only left in the numerator with n, so our answer is n. That one's a little bit more abstract of a thought process, but that is it. Let's take a look at our next section of notes. So the sum of the first n terms of a sequence is represented by sigma means summation. So the sum from I equals 1 to n of a sub I would be a sub 1 because that's where it's starting. The denominator tells you where it's starting. And then I shouldn't say denominator, the bottom tells you where it's starting and the top tells you where it's ending. So we start with a sub 1 because I goes, or 1 goes in the I spot, and we're counting all the way up to n. So then plus a sub 2 plus a sub 3 plus a sub 4 all the way up to a sub n. So it says I is called the index and n is called the upper limit. And for us, 1 was the lower limit. So practicing with sigma notation, we have our first one. So the sum from 1 to 5 of 3i. So we would have for 3i, the first one would be 3 times 1. But because it says summation, it's plus. And then 3 times 2 plus 3 times 3 plus 3 times 4. And then plus 3 times 5. Okay, 3 times 1 is 3, plus 6, plus 9, plus 12, and then plus 15. When you add them all together, you're going to get 45 as your answer. And again, we got this because the sigma sign means summation, so you're adding, but then we have 3i, so it's 3 times whatever you're placing in for I. Remember, it's from 1 to 5. Okay, let's look at the next one. We have the sum from 2 to 6 of 1 plus k squared. So for us, that will be 1 plus 2 squared, and then plus 1 plus 3 squared, because we're going all the way up to 6, plus 1 plus 4 squared, and then plus 1 plus 5 squared, and finally plus 1 plus 6 squared. That will give you as an answer 2 squared is 4. For the first one, 2 squared is 4, and 4 plus 1 is 5. Plus, on the second one, 3 squared is 9, 9 plus 1 is 10. Okay. Plus, on the third one, we have 4 squared, which is 16. 16 plus 1 is 17. Plus, on the fourth one, we have 5 squared, which is 25, plus 1 is 26. And then on the last one, we have 6 squared, which is 36, plus 1 is 37. If we add all of those values together, we will get 95. Okay. All right, let's try the last one. So on the last one, it is a sum from 0 to 8 of 1 over n factorial. Now, this is one for sure that we would want to use our calculator function for. And I'd have to show you in class how to use the calculator function, but there is a factorial button on your calculator. So to set it up, though, it would be 1 over 0 factorial, because it's from 0 to 8, plus 1 over 1 factorial, plus 1 over 2 factorial, plus 1 over 3 factorial, plus 1 over 4 factorial, plus 1 over 5 factorial, plus 1 over 6 factorial, plus 1 over 7 factorial, and then finally plus 1 over 8 factorial. In the end, it'll be about 2.71828. So it's about that amount. Not that it's exactly that, but about that amount. And again, I can show you how to set that up in your calculator once we're in class. Okay, let's move on to our next set. Okay, these are just some definitions of properties of sums. So on the first one, essentially what you have is a sum from I to n of some constant times whatever your function is. So if you have a constant, essentially you can move the constant to the front and say just the constant times the sum. So everything that we did, we could essentially take all of those sums that we just found a second ago, and if there's a constant, we could just multiply it times the final answer. On the second set, we have a sum from I to n of sum of functions being added together. So if they're being added together, you can separate them so that it's not as much work. So it could be the summation of the first part of the function plus the summation of the second part of the function. And same thing for the last one. If we have the sum from I to n of two functions being subtracted, you would do the summation of the first one minus the summation of the second one. Also, then we're going to talk about series. So the sum of all terms of the, that's supposed to say infinite. So not I infinite, but it's just infinite, so that E is not there. of the infinite sequence is called an infinite series and denoted by a sub 1, a sub 2, all the way up to whatever this a sub I value is. And essentially, it just, notice it doesn't have an end. So it just says plus dot, dot, dot at the end of it. So that means it's going on to infinity, okay? The second one says the sum of the first n terms of the sequence is called a finite series, or the nth partial sum. It's very rare that we really talk about, I mean, we don't really use the word partial sums. We mostly use just infinite and finite. But as you get into upper levels, you may see partial sums. So you need to know what that means. So partial sum is just about finites. So yeah. Of the sequence is denoted by a sub 1 plus a sub 2 plus dot, dot, dot. Notice that this one actually has a true ending. So this one has a stopping point, whereas this one did not. It kept going. Okay, and so that ending is located at the top, whereas this one didn't have an ending, so it's all the way into infinity. It's the main difference between the two. So let's try and solve it. So this one says, for the series below, find A, the third partial sum, and B, the sum. So if we want to find a partial sum, remember partial sum means that it actually stops. And so this one's saying from 1 to 3. So part A would be the sum from I equals 1 up to 3. So we would do that. So that'd be of 3 over 10 I to the I power. So that'd be 3 over 10 to the first plus 3 over 10 to the second plus 3 over 10 to the third. Okay. Leaving this in fraction form, or honestly, you can change it to decimals in a moment, you would get exactly 0.333 as your answer. Okay. On the second one, however, because it's just a sum, and if they ask you for the sum, then they are actually saying it as an infinite series. It would be the sum from I equals 1 to infinity of 3 over 10 to the I power. And so that would be, starting out, 3 over 10 to the first plus 3 over 10 to the second plus 3 over 10 to the third plus, just continuing on. But without us knowing, we know that this one would actually be, about 0.3 repeating, whereas this one stopped at 0.333, or in other words, 333 over 1,000. Okay. This one below, however, is closer to 1/3. So we actually end up getting two different answers. They look and feel very similar, but they are very different answers. Okay. We are done with this section, guys. If you have any questions, please be sure to come see me for tutoring.